All right, guys, here we are. We are going to solve some more linear equations, inequality word problems too. So much fun. We're doing it twice. These are going to look a lot like the other ones, but we're going to do some more, okay? Maybe some more little hints along the way. Papa John is 50 years old. His age is, okay, that's just doggone interesting. That just tells us all about Papa John. So this is where we're going to get our equation, okay? So remember, the word is gives us our equal sign. So see the is right there? That means we've got stuff in front of the equal sign and stuff behind. So there's my equal sign. What's in front? His age. Well, what is his age? Oh, it's 50. So his age, 50, is. Now this part, 2 years more than 3 times the age of Jimmy John, is going to go after the equal sign. Here's that more than. So remember, we're going to go back here. We need 3 times the age of Jimmy John. That's what we're trying to find out. We're trying to find out how old Jimmy is. So let's A be Jimmy's age, okay? Or let J. We need 3 times the age of Jimmy John, so 3 times Jimmy John and 2 more years. So we're going to subtract the 2. We get 48 is equal to 3J. This is multiplication. Remember, the opposite of multiply is divide, so we're going to divide by 3, and we get that Jimmy is 16. So our answer is Jimmy is 16. Okay, Jimmy can get his license soon and then go eat Jimmy John's or Papa John's pizza. That's what that reminded me of. Mr. Johnson said, 5 less than 1/4 of my age is 12. How old is Mr. Johnson? So let's let J equal Mr. Johnson's age. Look how lazy I am. Mr. Johnson's age. So remember what word we're looking for? You're looking for the word is. That's your equals. There it is. Here's my equals. Part goes before, part goes after. Here's the easy part, is 12. There's the is 12. Now remember, the other word you're looking for is if you see the word than, you start in the back. 5 less than, there it is, 1/4 of my age. What does my age mean? Well, Mr. Johnson's talking, so that's how old Mr. Johnson is. So we have 1/4 of Mr. Johnson's age, and then we went 5 less than that. So we're going to add 5. We get 1/4 of J is equal to 17. Remember, when we have a fractional coefficient, we're going to multiply by the reciprocal, which is 4/1, and that's the same as just plain old 4. 4 on top, 4 on bottom, 1 on top, 1 on bottom. I have J left. 17 times 4 is 68. Well, that doesn't go there. Oh my goodness. J is equal to 68. So what do we know? Mr. Johnson is 68. He is old, Mr. Johnson. He's even older than me. Whoa. Janie, we got like J's in this class, don't we? Janie receives an allowance of $3 per week. In addition, she can earn $2 for each chore she does. This week, she wants to earn enough money to buy a CD for $13. Apparently, Janie doesn't know about Spotify. Write and solve an equation to determine how many chores Janie needs to do this week in order to purchase the CD. So let's talk about what's happening. What's happening is, how much does Janie have? So what she has plus the change or the increase in her money, and that's going to give us the final amount, right? Is that what's going on here? What you got plus how much more you get is going to equal your final amount. So is there anywhere that tells us what Janie has this week? This week, how much did she earn? She got $3 just because she's cute as a button and mommy and daddy gave her $3. In addition, so we're going to add, she earns $2 for each chore. So she washes the dishes, $2. She mops the floor, $2. She cleans out the toilet, should be worth more, $2. She takes out the trash, $2. Every time she gets a chore, she earns $2. So how do we figure that out? That's $2 for each chore, and we want to know how many chores. So C is going to be the number of chores. So if it's $2 for each one, it's 2 times the number of chores. And she needs to get $13. Now, what if she gets $12.99? Not enough. If she gets 13, is that enough? We're going to pretend tax doesn't exist. If she gets 15, is she still in good shape? So she needs to have at least, so she needs more than $13. So if she needs more than, that's a greater than or equal to sign. So we're going to subtract 3, subtract 3. We have 2c is greater than or equal to 10, divide by 2. C is greater than or equal to 5. So she must do at least 5 chores because the number of chores is bigger than 5. So if I was looking at this, this is what it would look like if I graphed it, right? So how many chores? She could do 5 and have just exactly enough money. 6 would give her much. 7 would give her enough. 8 would give her enough. So she has to have at least 5 chores. So how many did I list? 4. She needs 1 more. Go home and do chores. Try to negotiate. Keith's dog weighs 90 pounds. A healthy dog for his weight would be less than 75 pounds. Keith's dog is overweight. If Keith's dog can lose an average of 2 pounds per week on a certain diet, how long until the dog reaches a healthy weight? So you could start at 90, right? Subtract 2, that would give you, I wouldn't write this down. That would give you 88. Subtract 2, that would give you 86. And we could keep on going until we get to less than 75 pounds. Or, oh, that's right. This class is called algebra. We could use algebra. Look how sad this dog looks. We shall call him George. George the dog looks sad because George has to lose weight. Poor George. No donuts, George. Okay, so this time instead of what she has, it's what the dog has, how much he weighs, minus what he loses is going to give us his final weight, right? So what does the dog have? How much weight does he have? He has 90 pounds. He's going to lose how much? 2 pounds a week. So just like $2 a chore, $2 a chore. So it's 2 pounds a week, 2 pounds a week, 2 pounds a week. So it's minus 2W. And we're going to let W equal the number of weeks, right? And that has to be, he has to equal 75 pounds to be healthy. So we want to know when that will equal 75 pounds to. Siri just started talking to me. Creepy, creepy. All right, so let's subtract that 90. So we have negative 2W. Don't lose your sign. 75 minus 90 is negative 15. We're going to divide by negative 2. Be careful, the negatives cancel, and you get 7.5. So it will take him in 7.5 weeks, he'll be a healthy weight. So if we're going by weeks, you could say 7.5 or you could say 8 weeks if we do a whole week, okay? This is one of those questions your teacher will know if you watch the video if you ask. What's the answer here, lady? I don't know. All right, now I believe that we talked about consecutive integers in 1.5, right? So important, we're going to review them. Do you remember that consecutive integers, if we go in order, here's the first integer, then there's the next one, then the next one, then the next one. So if we start with x, to get to here, we add 1. To get to here, we add 2. Remember even and odd? We start with an even, the next one's odd, the next one's even, the next one's odd, the next one's even, the next one's odd, and so on. For odd, we start with odd, the next one's even, the next one's odd, the next one's even, the next one's odd, and so on. So if we start with x, to get to the next even, I have to add 2. To get to the next odd, I have to add 2. To get to the second even, I have to go 1, 2, 3, 4 away. So I have to add 4. For the odd, 1, 2, 3, 4 away. So I have to add 4. That should already be in your notes, but remember, always good to have it twice. Oh, this is going to be a decent video, guys. I'm almost done. So we've got 2 consecutive odd integers. So I'm going to fill in the odds. Start with x. What's the next one? Remember, odd, even, odd. So I have to add 1, 2. have a sum. A sum means I'm going to add, right? That is at most 56 inches. So let's talk about our two odd. We've got x and x plus 2. If we add that, we get 2x plus 2. So that's the sum of our two odd. So 2x plus 2. Now here's the deal. I don't want them to equal 56. I want them to be at most 56. So you are at the amusement park, and here is a roller coaster. Flippity-doo-doo-doo. You want to go on this roller coaster. But there is a little alligator. I don't know why he's an alligator. There's his mouth, because I can't even draw an alligator. There's his tail. I don't know what alligator. There he is. Anyway, don't even, looks like a duck. He's holding out his hand, and he said, you must be at least this tall to ride the ride. Can you be shorter? Can you ride if you are shorter? No. You have to be greater than that, right? Except it says at most. So let me change all that. You have to be at most this tall. So can you ride if you are taller? No, you have to be shorter. You have to be down here to be at most this tall, because you would be too tall. I kind of read that wrong, so a roller coaster was not a good example, but I'm already done, so we're going with it. So at most is less than or equal to, and it's got to be less than or equal to 56 inches. If you're taller than 56 inches, you'll hit your head. Okay, we're going to subtract 2. So 2x is less than or equal to 54. We're going to divide by 2. X is less than or equal to 27. Now I didn't flip because I didn't divide by a -1. So if I'm looking at my number line, here's 27, here's 26, here's 25, here's 24. So it says find the pair of integers with the greatest sum. So what that means is if x is 27, what's the next odd integer that would give me at most 20 or 56? So my numbers are going to be 25 and 27. That one's craziness. Craziness, craziness, craziness. Okay, next one. Find two consecutive integers. So I'm just consecutive, and it's just 2. So the first one's x. Remember, I just add 1 because when I'm doing consecutive, I just want to go to the very next. Such that 7 times the smaller. So which one's smaller? This one's smaller, right? So that's 7 times the smaller is less than, now we don't go backwards because you see that word is? Remember, is what gives us our equals. When we have is less than, that's going to give us an inequality. Is less than, what's it less than? 6 times the greater. So 6 times, there's the greater integer. Okay, so over here I have 7x, keep your less than, distribute 6x plus 6. I'm going to subtract that 7x. So I have x is less than 6. What is the greatest such integers? So if I'm less than 6, again, here I am at 6, at 5, at 4, at 3. So can 6 be my number? Nope. So it would have to be 4 and 5. Okay, those last two are rough, guys. That might be a conversation you're going to have in class. So there we go. Less than 15 minutes. That is day 2. We are almost done with word problems, although we have them all year. Anyway, have a wonderful day. See you later, alligator. After a while, crocodile.